We will start with chapter number 2, which is about speed, velocity, and acceleration. So let's discuss about speed and velocity. Speed, the velocity of an object is the amount of distance it covers in a specific time period. Speed is classified as a scalar quantity. This is due to the fact that it only has a magnitude and it does not have any direction. If we need to calculate the speed of an object moving at a constant rate, we can apply the formula speed is equals to distance traveled over time taken, where velocity unit is meter per second, the distance unit is meter, and the duration is recorded in seconds. It is very, very important in physics to, whenever we do the calculation, we always need to mention about their units. The formula for average speed is distance traveled by time taken. The equation for calculating average speed along with equation for speed can be rearranged using the formula triangle shown below. So we can see here total distance, average speed, and time taken is in one triangle. How we can use it? Time is equals to distance over speed. Speed is equals to distance over time. And distance is equals to times speed. You can use these formulas in order to calculate as per the requirement of the question if they ask you for time, speed, or distance. Here is one worked example as well. An object travels at 250 meter per second. Hence, 250 is an average speed. We need to determine the overall distance covered over a duration of 2 hours. Here we need to convert these 2 hours, which is the time. We have mentioned our speed formula, distance traveled by time taken. If we need to calculate the total distance, average speed and time will be multiplied. Our time is given in 2 hours, hence we need to convert it into seconds first. So 2 times 60 times 60, as 1 hour has 60 seconds. So 2 hour we have given, so we will multiply by 62 times. Total distance is equals to time multiplied by average speed, and the distance will be in meters. Let's talk about velocity now. Velocity of an object includes both magnitude and direction. Velocity is a vector quantity. Vector means it has both magnitude and direction, since it conveys both size and direction. The formula for velocity that we have to remember is displacement over time. We are not using distance here because distance does not have direction and displacement do have. So our formula will be velocity equals to displacement over time. Displacement is s and time is t here. Since velocity is a vector quantity, it has displacement instead of distance, which is a scalar quantity. Let's talk about acceleration. It refers to the change in velocity over time. So change in velocity divided by change in time. This sign is a delta sign. This sign shows change. So if I need to show the change, I will be needing two velocities, final velocity and initial velocity. So final velocity minus initial velocity will give me the change in velocity. The unit for acceleration is meter per second square. Delta V is the change in velocity in meter per second, and delta t is the time taken in seconds. The variation in velocity is determined by subtracting the initial velocity from the final velocity. So delta V is equals to final velocity, which definitely will be greater than the initial velocity. Initial velocity is shown as u and final velocity is shown as v. Final speed measured in meter per second is v, and u is the starting speed expressed in meter per second. Let's discuss about speeding up and slowing down. An object that increases its speed is said to be accelerating. An object that decreases its speed is referred to as decelerating. The acceleration of an object can be either positive or negative based on whether it is speeding up or slowing down. When an object is gaining speed, its acceleration is considered positive. When an object is losing speed, its acceleration is regarded as negative, often referred to as deceleration. Here in this image, you can see a rocket that is gaining speed. Hence, it is acceleration. Similarly, a car with a reducing speed, we will call it as decelerating. Here we have one example to calculate the change in object's velocity and to calculate deceleration. The given information is an object in a constant speed traveling in a straight path. Its speed reduces from 50 to 42 meter per second, and the time is mentioned over a period of 30 seconds. So we need to calculate the change in object's velocity given initial velocity and the final velocity. The formula is final velocity minus initial velocity. Hence, its deceleration due to its negative sign. If we need to calculate part 2, which is acceleration, which is equals to change in velocity over change in time. Change in velocity we already have calculated. Change in time we need to calculate, whereas time given is 30 seconds. So you just simply divide minus 8 by 30, and our acceleration negative is minus 0.27 meter per second. The answer is negative, which indicates that the object is slowing down. Let's discuss about distance. It is the total length of the path traveled by an object without considering direction. We have distance time graph also, which can illustrate the distance of an object traveling in a straight line changes with time. Using the distance time graph, we can see that the velocity of an object in motion can be determined by the slope of the line on the distance time graph. Speed is a gradient is equals to rise over run. So this is run, this is rise. Our gradient is rise over run. Our vertical y is distance and our horizontal x is time. The velocity of an object can be determined by finding the slope of a distance time graph. Slope is equals to change in y over change in x. The rise represent the difference in y and the run represent the difference in x. So our slope formula will be change in y over change in x. Change in y is equals to y2 minus y1, and change in x will be equal to x2 minus x1. We need to calculate the speed of an object. If the distance covered rise is 8 kilometers, which is 8,000 meters, and the run the duration, which is 6 minutes, which is equals to 360 seconds. Our speed formula, rise over run. We simply divide our rise over run and we will get our speed in meter per second. With this, we have finished our this chapter. See you in our next chapter.